Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the reordered power of 2 problem. So we are given an integer n, we reorder the digits in any order, including the original order, such that the leading digit is not 0. Return true if and only if we can do this so that the resulting number is a power of 2. Well, in a previous question we talked about powers of 4, and we also discussed powers of 2 in that, so we know how to detect a power of 2. It's something that has exactly 1 bit set in its binary form. The question is, so for example, if we're given 256, obviously 256 is a power of 2, so we know the answer immediately. The trickier question is so how can we go if we know 256, for example, do we know 625? Obviously it's not a power of 2 because it ends in an odd number, but we could do a permutation of it. And the reason that worries me is because here the numbers can be quite large. 9 digits long. And if we want to get all permutations of 9 digits, that's a lot of permutations. So we can't do that. We cannot test a number to see if some permutations of its digits can be a power of 2. Which leaves us with the question, if we can't do the obvious thing, what can we do? If I can't test all combinations of the input, okay, so how many so let's think about this. 10 to the 9, that's 2q, 3, 9, 20. So that fits in one 32-bit integer. So how many powers of 2 are there in 32-bit integers? Well, there's 32 of them. It's each of the binary strings with one set. So that set is actually very small. And if we take all of those powers of 2 and generate the permutations of their digits, no, that's still too many. But we don't need to know the permutations of their digits. We just need to know their digits. So hang on. Powers of 2 is equal to the set of 2 to the power of I for I in range 0. So my rough back of the envelope here is 10 is roughly 2q, roughly 2. So 10 to the 3 is roughly 2 to the 10. So 10 to the power of 3 is approximately equal to 2 to the power of 10. I'm just going to stick a comment in front of this. So that means 10 to the power of 9 is equal to 10 to the power of 3, not 100, 10 to the power of 3 to the power of 3. Therefore that's approximately equal to 2 to the power of 10. Why did I change this notation now? To the power of 3 is equal to 2 to the power of 30. So we know this fits in a 32-bit integer. So that's why I can do this. And the reason I'm happy to do this and not say 31 is because I knew 2 to the 10 is actually a wee bit bigger than 10 to the 3. This is 1024 and this is just 1000. So this is going to be very slightly larger. In fact, let's change that inequality. So we know this is fine. So this is my set of powers of 2. And the digits of powers is going to be set stir p for p in powers of 2. In fact, I don't even need to. Oh, jeez. So this now gives me all of the. This gives me a set of sets where each set contains all the digits of this prime power. Sorry, not prime power, 2 power. So then all I want to do is digits is the set of the stir of n. Return digits n digits of powers. Now this won't work because sets can't contain sets, but they can contain frozen sets. This might work. Let's run it and see. I don't think it should be too slow, because this is only 30 steps. This is only 30 steps. Well, depends how long this takes, but it's not bad. Set lookup is order 1. So it should be pretty good. Excellent. I'm just trying to wonder if there's leading digits is not 0. I think this takes that into account, because here this string representation doesn't include leading zeros. So the reason it's trying to say that is because 0, 1 can't be turned into a 1, 0 can't be turned into 0, 1 and then argue, oh, but that's power of 2. No, we're not going to allow that. And I think that's useful for us, because then we'd have to sort of implicitly add a 0 to each of these sets. Ugh. So we don't allow that. Don't need that comment. Let's submit it and see what happens. I can't do it with a set. I need to do it with a multi-set. How can I do this? Collections. Let's just do digits here. So digits of some number is going to be stir n, and what I want to do is I want to do a collections counter of those. I want to get the items from it. So what that should do is it should count each digit. So here it should give me 2 1s, 1 5, and 1 2. And I want to turn that into my set, effectively giving me a multi-set rather than what I had before. So let's just test it again here. Oops. And actually, let's go into our test case and do 1521. That seems to be working better. Submit again, and there's always an edge case you forget. That's perfect. Gone. Excellent. So we're not super fast, not bad. Memory usage is great, but then again, these probably all cluster around a similar number, unless people are building huge hash tables. I don't know. Interesting question, interesting problem. It leads you down the path of, oh, I'm going to have to look for this n and n-1 business again, but you don't. You have to do something actually with the digits itself. Cool problem. Quite enjoyed it. Thank you everyone again for watching. Remember to like, comment, subscribe, all of that good stuff. If you're in the UK, have a good long bank holiday weekend. And for the rest of you, have a good weekend anyway. I will see you all next time. Bye.